Hello guys, my name is Talha Khan and welcome to my MIS 303 iVlog 2. In this vlog, I'll be talking about chapters 4, chapters 5, and chapter 6. So let's start with chapter 4, domain modeling. So what is problem domain? Problem domain is the specific area of the user's business that is included within the scope of the new system. Domain classes, or data entities, are what end users deal with when they do their work. These are often referred to as things in the context of a system's problem domain. The new system involves working with and remembering these things. Often things are related to the people who interact with the system or to other stakeholders. For example, a customer is a person who places an order, but the system needs to store information about that customer. So a customer is also a thing in the problem domain. Moving forward, we have many techniques for identifying the important things in the problem domain that the system needs to remember. Two of them are introduced in this chapter, the brainstorming technique and the noun technique. The brainstorming technique is used to identify problem domain classes where developers work with users to identify different types of things that they use in their work. Next, we have the noun technique, which is a technique used to identify things in the problem domain by finding and classifying the nouns in a dialogue or description. Next, we have the domain model class diagram. Now, before we define what a domain model class diagram is, we need to break down the term and define what a class is, what a domain class is, and what a class diagram is. Class is a category or classification used to describe a collection of objects. Each object belongs to a class. Therefore, students like Mary, Joe, and Maria belong to the class student. Classes that describe things in the problem domain are called domain classes. Domain classes have their own attributes and associations. A class diagram consists of classes or set of objects and associations among the classes. In the UML notation, we call these associations multiplicity, and the ERD notation we call them cardinality. So the domain model class diagram is a class diagram that only includes classes from the problem domain. Now, moving on to chapter 5, use case modeling. So what are fully developed use case descriptions? A use case description is a textual model that lists and describes the processing details for a use case. A fully developed description is the most formal method for documenting a use case. One of the major difficulties for software developers is that they often struggle to obtain a deep understanding of the user's needs. But if you create a fully developed use case description, you can increase the probability that you thoroughly understand the business process and the ways the system must support them. Next, we have the UML activity diagrams. So UML activity diagrams are just another way to document a use case. In Chapter 2, we learned about activity diagrams as a form of workflow diagram that might cover several use cases. Activity diagrams are also used to document the flow of activities for just one use case. Sometimes an activity diagram can take the place of the flow of activities section of a use case descriptions, and sometimes it is created to supplement the use case description. Next, we have SSDs, or system sequence diagrams. So a system sequence diagram is a special type of UML sequence diagram that show the sequence of messages between an actor and the automated part of the system during a use case or scenario. In the object-oriented approach, the flow of information is achieved through sending messages either to and from actors or back and forth between internal objects. Thus, an SSD documents the inputs and the outputs and identifies the interaction between actors and the system. It is an effective tool to help the initial design of the user interface by identifying the specific information that flows from the user into the system and the information that flows out of the system back to the user. Moving on to Chapter 6, the foundation for systems design. So what is system design? Chapter 1 defined the term system design as those system development activities that enable a person to describe in detail how the resulting information system will actually be implemented. That definition was preceded by a definition of systems analysis, which is those activities or those system development activities that enable a person to understand and specify what the new system should accomplish. The sequence of the definitions implies that analysis precedes design. That is, to design anything, you must first understand and specify what the final product will accomplish. What are system design activities? So system design activities are as follows. Describe the environment, design the application components, design the user interface, design the database, design the software classes and methods. Now, system design involves specifying in detail how a system will work when deployed within a specific technology environment. Some of the details may have been defined during system analysis, but much more detail is added during the system design activities. In addition, each part of the final solution is heavily influenced by the design of all other parts. Thus, system design activities are usually done in parallel. For example, the database design influences the design of application components, software classes and methods, and the user interface. Likewise, the technology environment drives many of the decisions for how system functions are distributed across application components and how those components communicate across a network. When an iterative approach to the System Development Lifecycle, or SDLC, is used, major design decisions are made in the first or second iteration. However, many decisions are revisited and refined during later iterations. So with that, I would like to conclude and thank you for listening to my MIS 303 iVlog 2.